The living world is a universe of shapes and patterns, beautiful, complex, and sometimes strange. As what Ian Stewart point of view is that we live in a universal patterns. Before we tackle natural world, let me introduce to you my groupmates. Karel Casalda, Aldrich O, Moshgail, Joastain, and Carmel Kilaiko. Chapter 1, page 1 and 2.
Chapter 1. Here's a summary and highlighting important points. Summary. The text discusses the prevalence of pattern in nature. It begins by stating that we live in a universe governed by patterns like the movement of stars, seasonal changes, and the symmetrical shapes of snowflakes. Animals like tigers, zebras, leopards, and hyenas also exhibit pattern markings. The text then explains that humans have developed mathematics as a formal system to understand and utilize these patterns. At key point, it concludes by mentioning Johannes Kepler's work with the six concerned snowflakes, which argued this point 400 years ago. Important highlights. Ubiquity of patterns. The text emphasizes the widespread existence of patterns in the natural world, from celestial bodies to animal markings and weather phenomena. Second, mathematics as a tool. Mathematics is presented as the essential tool for understanding and organizing our knowledge of these patterns. Third, patterns as clues. The most significant point is that natural patterns are not just visually appealing, they are vital clues to understanding the fundamental principles governing natural processes. And lastly, Kepler's contribution. The text highlights Johannes Kepler's early recognition of the importance of patterns in nature, demonstrating the long-standing interest in this concept.
Chapter 1, pages 2 and 3.
The natural order and nature's number. The important natural order and nature's number. The important key points in here are recognizing patterns is useful and exceptionally these patterns often stand out. The planet fractals and chaos are types of pattern found in nature. Numerical patterns exist in nature such as the phases of the moon and the number of legs on different animals. Flower petals commonly have numbers corresponding to the sequence 3, 5, 8, 13, 21, 34, 55, and 89. Numerology can be a dangerous method for finding patterns because it's difficult to distinguish significant patterns from accidental ones. Kepler looked for mathematical patterns in the behavior of the planets and found a pattern relating a planet's orbital period to its distance from the Sun.
And continue chapter 5 and 6.
It discusses the dangers and ease of finding numerical patterns in nature, specifically through numerology. It uses the example of Kepler's search for mathematical patterns in the solar system. Kepler's discovery of a relationship between a planet's distance from the Sun and its orbital period was significant, leading to advancements in Newton's theory of gravity. However, his idea of there being exactly 6 planets was an incorrect and oversimplified theory. The passage highlights the problem of numerology. It generates many accidental patterns for each significant one, making it difficult to distinguish which patterns are truly universal.
The key terms of our natural, which is, for example, circles in nature, experience in rainbow, ripples in ice, spirals, scenes in shell, ripples, and hurricanes. And third, wave, found in the ocean, rivers, air flows, and even animal movement. Fourth, verticals, vortex, rotating patterns in liquid, ripples, and tornadoes. Fifth, sand dunes, created by wind and desert, type of Gaussian, parabolic, and star-shaped dunes. Six, animal patterns, which is stripes, tigers, zebras, spot, leopards, and symmetries, like for example starfish, viruses. 7. Locomotion patterns, which is repetitive movement rhythms in walking, flying, and swimming. This is the key points and the critical terms that should be explained our group.
And other examples in natural world and mathematical. Helical motion in nature. Some organisms like bacteria use helical movements for propulsions similar to a ship's crew. And also newly recognized natural patterns. Some patterns in nature previously thought to be random have only recently been identified and understood. Another one is cloud shape and scale independence. Clouds do not follow conventional geometric shapes but exhibit a distinctive pattern. Their forms does not systematically depend on size, making it difficult to determine their scale just by looking at them. Another one is fractal nature of clouds. A phenomenon of scale independence clouds has been experimentally verified, showing that cloud patches can vary in size by a factor of 1,000 without a clear visual indication of their absolute scale.